All right, so when we look at section 9.1, we're on page 419, if you open up there. The title of this section is Parallelograms. This is how you spell it. Parallelograms. The name should tell you a lot. It's a special type of quadrilateral. So let's get the terminology out of the way. A quadrilateral is a four-sided polygon. And there are some characteristics about a parallelogram that we could discover, but today, just for expediency, I'm just going to share with you some of the different qualities, especially unique qualities for parallelograms. All right, so first of all, I like to look at a parallelogram as a tilted over rectangle. So if we think of a rectangle, I know we're all familiar with a rectangle. If we think of a rectangle, all a parallelogram is a rectangle that's leaning over. We'll add a little C to that rectangle so we get everything right. All right, so kind of a tilted over rectangle. Now, some qualities of a parallelogram. Let's start with the first obvious one. Opposite sides are parallel. So if I'm going to give it the right little denotions, that's what that looks like. So we have an arrow on top and an arrow on bottom. Okay. So now, when I look at that, if I extend this, this should look familiar. Remember us doing problems with two lines of parallel, what angles are supplementary and what angles are complementary and all that? Okay, so then, if I only look at the inside of those two lines which are parallel, see if I can outline this. The parallelogram is this part right here. All right, so now, if you remember, if this was angle 1 and that was angle 2, and we know that the opposite sides are parallel, what's true about angle 1 and angle 2? What kind of angles are they? Same side interior angles. Angle 1 and angle 2 are same side interior angles. What do we know is true about same side interior angles? Anybody remember?
Supplementary.
They are supplementary, that's right. With the S's, alliteration, same side interior angles are supplementary. So we're going to transfer that understanding to parallelograms. And we're going to say it like this. Opposite sides are parallel, so here's another truth. Because the opposite sides are parallel, we're going to say it like this. Consecutive angles are supplementary. What do you think we mean by when we say consecutive angles? Madison, what do you think?
They're next to each other?
Yeah, if you're like working your way around a parallelogram, for instance like this, here's another parallelogram. If we're working our way around, and I have angle 1, angle 2, angle 3, and angle 4, working our way around, Angle 1 and angle 2 are what we would call consecutive. Okay. Angle 2 and angle 3 are consecutive. Angle 3 and angle 4. And angle 4 and angle 1. Those are all consecutive angles. And again, if you can just relate back to earlier info that we've talked about, if I extend these sides, it should make sense that these are supplementary because they are same side to your angles. So again, if angle 2 is 120 degrees, then I know that angle 1 is 60. If angle 2 is 120 degrees, then I know that angle 3 is 60. So looking at that, thank you, Scott. So looking at that, if I have 120 degrees, 60 and 60, what do I know is true about angle 3 and angle 1? No, they're not complementary. Complementary means they would add up to be 90.
They're congruent.
They're congruent, always. That's another truth or conclusion that we can have for parallelograms. So let's make another one here. And we're going to call those opposite angles. They are congruent. Opposite angles are congruent. So angle 1 and angle 3, and angle 2 and angle 4. That's always the case. Angle 1 and angle 3, angle 2 and angle 4. Opposite angles. Okay. All right, so I kind of jumped over a few things that they referred to in the book, but there's a let me back up just a tad bit, and there's another thing that we know about rectangles. So go back to the beginning picture. What do we know about the opposite sides in rectangles? They're parallel. True. What else? What about their lengths? They're congruent. That's right. We know that this side is equal to this side, and this side is equal to this side. Okay, well, since this is just a tilted over rectangle, that's also true of parallelograms. So not only are opposite sides parallel, opposite sides are also congruent. So by their name, they're parallel, but they take on a little bit of the characteristics of a rectangle, and that the opposite sides are congruent. Okay? All right, there's really only one more conclusion, quality that we need to come up with when it comes to a parallelogram, and here it is. Let me draw another parallelogram. Make this a little bit bigger. So there's a parallelogram, A, B, C, D. By the way, sometimes they'll denote a parallelogram like this. That's how they'll say, there's parallelogram A, B, C, D. And they'll just use like a basic little parallelogram symbol. Okay? So parallelogram A, B, C, D. Now, let me draw in the diagonals. So I'm going to connect the opposite angles, the opposite vertices. All right, so I've connected the diagonals. And here's the last quality that we're going to specifically talk about with parallelograms. That the diagonals bisect each other. The diagonals bisect each other. So, if I put an M here, that means that AM is equal to CM and DM is equal to BM. So this is a midpoint of the diagonals. Going with me? Good? All right, so let's summarize all that we've talked about with parallelograms. So draw this in your notes, okay? Here we go. A big circle at the top. And write the word in it, parallelograms. All right, what a parallelogram looks like is this. So just put a little bit of a sample one in the circle. All right, got it? All right, so now over here to the left, off of that one, draw another circle. I'm going to label these sides real quick. A, B, C, and D. And here we're going to say opposite sides are congruent. That means, in this picture, that AB is congruent to CD and AD is congruent to BC. So that's one characteristic. And then over here, draw another circle. Here's the second thing that we've learned already. Opposite angles are congruent, and consecutive angles are supplementary. So opposite angles are congruent, consecutive angles are supplementary, which means this, that angle A is congruent to angle C, angle B is congruent to angle D, and angle A plus angle B equals 180, angle B plus angle C equals 180, and I could keep going, but I don't need to write it anymore. Consecutive angles are supplementary. These are all the characteristics so far. Just in a quick review, one more. The diagonals bisect each other. So our third and final. Okay, so then I didn't draw it in the original picture, and that's okay, but you know that AC and BD bisect each other. So if there were a midpoint there, like this, call DE, then we know that AE is congruent to CE, and DE is congruent to BE. So we have a pretty nice summative look at the qualities of a parallelogram. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other, AC and BD bisect each other, AE equals CE, and DE is congruent to BE. All right, questions on that? Let's do a couple examples. Turn in your book to page 425. So page 425, let's do number 8 and 9 together. All right, so our picture looks like this. If I can recreate that picture. Page 425, we've got a parallelogram. It says PQRS is a parallelogram. That's given. And then we've got an intersection of T. I'm going to focus in just a little bit so we can see this a little bit better. So now, lengths of sides. We have x plus 9, and that's right there. This side over here is 3z minus 4. Has everyone seen the picture in their book? Okay, good. Make sure I don't do something incorrectly here. 4x minus 6 goes to that segment. And then, is that 2z plus 4? My eye is playing tricks on me. 2z plus 4, is that what you guys see? Yeah. Yeah? Okay, good. All right, so that looks like the all the given information and for number 8 and number 9. Let's do number 8 first. It wants us to find the length. Remember, if it doesn't have a segment on the top, that means the length of. It wants to find the length of QR. All right, well right now we know that QR is 3z minus 4. And so I think of the qualities of a parallelogram telling me that the opposite sides are congruent. Okay? So I can find what z is by setting it equal to the other side. So I'm going to set up an equation. 3z minus 4 is equal to 2z plus 4. We got everything right? Yep. So I'm going to use that given info and solve for z. Subtract 2z from both sides. Z minus 4 is equal to plus 4. Now I'm going to add 4 to both sides. And I have z is equal to 8. Now that doesn't answer the question, but it gives us the value of z in order to find the length of QR. So we know that QR is equal to 3z minus 4, and we know that 8 is equal to z. So we're going to take 8 and plug it in. 3 times 8 minus 4, 24 minus 4, QR, our final answer, is equal to 20. Any questions on that? Pretty straightforward. All right, let's take a look at number 9. If we can get it on the screen up here. Number 9, with that given information, imagine they're going to do something very similar with the diagonals. They want us to find the length of PR. Well, PR is the entire diagonal. Okay. Well, we know again that they bisect each other. So that means that PT is equal to RT because of the quality that the diagonals bisect each other. Good? So I'm going to set those expressions equal to each other. X plus 9 is PT, and 4x minus 6 is RT. Just a quick substitution there. Now let's solve for x. So 9 then is equal to 3x minus 6. 3x then is equal to 15 when I add 6 to both sides. Divide by 3, and 5 is equal to x. Again, that's not what they're looking for. They're actually looking for PR. Well, I can put that into either one. If I put it into x plus 9, 5 plus 9 gives me 14. Is that what they're looking for? That's only half of it. So I could just say multiply it by 2 because it bisects it, or I could put 5 into the other one. Either way, I know that I'm going to multiply this by 2. They're both going to be equal to 14. And so the length of PR is equal to 28. All right, questions on that? That basically is section 9.1. We've got 3 major concepts for parallelograms. It's a rectangle that's tilted over. Opposite sides are congruent, parallel, diagonals bisect each other. Opposite angles are congruent, and consecutive angles are supplementary. All right, that's it. Here's our homework. We're going to steer away from the proofs, just so you know that, at least for these parallelograms. Okay, so we'll start with page 427. We'll start with number 6, and we'll go through, like I said, we're going to try and steer our way away from, we might do one proof, but not as many as they want us to do. We go 6 through 13, and then 16, through 23. No, make that 24. All right, page 427, 6 through 13, 16 through 24. That's it. Thanks.